Hi, welcome to my channel. In this video, we want to solve the following problem. In triangle ABC, angle ABC equals 3 theta and angle BCA equals theta. Point D lies on BC such that AD bisects angle CAB. Given that AC equals 2 square root 3, BD equals 1, and DC equals x, the goal is to find x. And now for the solution. First, let us denote the length of AB as A. Next, let us apply the angle bisector theorem. Given a triangle with these dimensions, the theorem tells us that A over B equals P over Q. By the angle bisector theorem in triangle ABC, we have A over 2 square root 3 equals 1 over x, or A equals 2 square root 3 over x. Let P be on AC such that the length of AP equals A. Then the length of PC equals 2 square root 3 minus A. Join D to P and then consider triangle ABD and triangle APD. We claim that triangle ABD is congruent to triangle APD. Since AB equals AP, angle DAB equals angle DAP, and AD is common to both triangles. By the SAS congruency test, the two triangles are congruent. Since BD and PD are corresponding sides in congruent triangles, we have PD equals BD equals 1. Similarly, angles ABD and APD are corresponding angles in congruent triangles. Therefore, we have angle APD equals angle ABD equals 3 theta. Following this, consider triangle DCP and the line AP. Angle DPA is an exterior angle of triangle DCP. Since an exterior angle equals the sum of interior opposite angles, angle PDC equals 3 theta minus theta, which equals 2 theta. Next, let Q be on PC such that angle PDQ equals theta and angle QDC equals theta. Let us denote the length of PQ as B. Then the length of QC equals 2 square root 3 minus A minus B. Since angle QDC equals angle DCQ equals theta, triangle DCQ is isosceles. The length of DQ thus equals 2 square root 3 minus A minus B. Finally, consider triangle DQP and triangle CDP. We claim that triangle DQP is similar to triangle CDP. Since angle PDQ equals angle PCD equals theta, and this angle is common to both triangles, by the AA similarity criterion, the two triangles are similar. Since corresponding sides in similar triangles are proportional, we have DQ over CD equals QP over DP equals DP over CP, or 2 square root 3 minus A minus B over X equals B over 1 equals 1 over 2 square root 3 minus A. From B over 1 equals 1 over 2 square root 3 minus A and A equals 2 square root 3 over X, we have B equals 1 over 2 square root 3 minus 2 square root 3 over X. Multiplying the numerator and denominator by X, we obtain B equals X over 2 square root 3 times X minus 1. Substituting B equals X over 2 square root 3 times X minus 1 and A equals 2 square root 3 over X into 2 square root 3 minus A minus B over X equals B over 1 gives 2 square root 3 minus 2 square root 3 over X minus X over 2 square root 3 times X minus 1 divided by X equals X over 2 square root 3 times X minus 1. Simplifying the left hand side to 2 square root 3 over X minus 2 square root 3 over X squared minus 1 over 2 square root 3 times x minus 1, and multiplying both sides by 2 square root 3x squared times x minus 1 yields 12x times x minus 1 minus 12 times x minus 1 minus x squared equals x cubed. Expanding and rearranging gives the cubic equation x cubed minus 11x squared plus 24x minus 12 equals 0. By the rational roots theorem, any rational root is a factor of 12. Testing shows that x equals 2 is a solution. With this in mind, let us write minus 11x squared as minus 2x squared minus 9x squared, and write 24x as 18x plus 6x. We then factor x squared from these terms to obtain x squared times x minus 2. Factor minus 9x from these terms to obtain minus 9x times x minus 2. And factor 6 from these terms to obtain 6 times x minus 2. The left-hand side thus factors as x minus 2 times x squared minus 9x plus 6. Therefore, we have x equals 2 or x squared minus 9x plus 6 equals 0. When x squared minus 9x plus 6 equals 0, applying the quadratic formula with a equals 1, b equals minus 9, and c equals 6 gives us two possible solutions. x1 equals 9 plus square root 57 over 2, which is approximately 8.275, and x2 equals 9 minus square root 57 over 2, which is approximately 0.725. A third solution is then x3 equals 2. To determine the possible values of x, let us return to the diagram. For x1 equals 9 plus square root 57 over 2, AB plus AC is approximately 3.883, while BC is approximately 9.275. Then AB plus AC is less than BC, which violates the triangle inequality, so we reject x1. For x2 equals 9 minus square root 57 over 2, we have x2 is less than 1, and so 1 over x2 is greater than 1. Thus, AB, which equals 2 square root 3 over x2, is greater than 2 square root 3, which equals AC, meaning AB is greater than AC. But AB is opposite the smaller angle, thus, we require AB is less than AC. Hence, we have a contradiction, and so we reject x2. Therefore, x3 equals 2 is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.